if there's evidence that mu is not equal to 5, in other words, that mean diameter is not 5, the machine is adjusted. It means they shut the machine down, stop everything, adjust the machine, because your bolts have to be 5 millimeters, and they only allow a certain amount of error. Okay, 95% confidence interval. Okay, so in one particular sample, the mean diameter was 5.08 millimeters with a standard deviation of 0.11 millimeters. Calculate the interval and decide if you need to adjust the machine. So we need to calculate a confidence interval, and then we need to use it to decide if we should adjust the machine. And this is more and more what your stats questions are going to be going to. Do this and then make a decision. Okay? Do this test and make a decision. This isn't really a test, we're just writing a confidence interval. So we are the bolt sampler and the statistician. Okay? Actually, the statistician probably would have a personal bolt sampler. Okay? They would send them to measure the bolts and bring back the data. So we know that 5.08 is what in our problem? That is X bar is 5.08. Okay? And 0.11 is S, and it's the sample standard deviation. None of these are true values. What do we want the mean to be? What is our true mean? What do we need it to be? 5. Okay, so this is our comparison at the end. That's our comparison at the end. In other words, really what we need to do is we need to write a confidence interval based on this sample information, and then say, is that number in the confidence interval? Is 5 in the confidence interval? Because if it is, then the bolt machine is capturing 5 more times than not. Okay, if 5 is in the interval, the machine is probably good. If 5 is not in the confidence interval, we probably need to adjust the machine. All right, so first thing we need to do, step 1, we need to say what we're doing. So step 1, we are trying to estimate. What are we trying to estimate?
The mean.
True mean of the what?
Diameter.
True mean diameter of the bolts. Of bolts. Okay, that's mu. Okay, so that's what we're trying to do. Trying to estimate the true mean diameter of the bolts. Okay, what do we have? Our best guess is what?
5.
Our best guess is X bar is 5.08 millimeters. But what? But is probably, yep, okay, we can write probably incorrect due to what? Okay, due to sampling variability. So I will, what will you do? Calculate. Oh my gosh, I can't spell today. Okay, calculate a what? What percent? 95%. What type of interval? T interval, good. For what variable? Mu. Always use the true value when you describe the type of confidence interval. P, mu. All right, so step 2, what do we have to do in step 2? Check the conditions. So the first condition, does it say it's a random sample of bolts?
Yeah.
Okay. Stated as a random sample of bolts. Okay. 2. Assume how many bolts? 15 bolts is what? Less than 10% of all bolts. And third, large sample size. Is N greater than 30? No. N is not greater than 30. So next thing.
Isn't it you say what we believe that this is representative?
Yes. N is not greater than 30. Now, the other thing is, does it say it's from a normal distribution? No, it doesn't. So n is greater than 30. So, yeah, we can assume population of bolts is normal. Or the other option would be I'm going to proceed with caution. Since n is not greater than 30, I'm going to proceed with caution. So, but you can assume it's normal or proceed with caution. Either one would be acceptable. All right, so now what's step 3? Calculate the confidence interval, right? Have I even given you the formula?
Nope.
Nope, but guess what? You should know it. The formula for a confidence interval is your point estimate plus and minus the margin of error. Okay, the margin of error is always made up of your critical value and your standard deviation. So what's my point estimate? What statistic am I calculating from my bolts? X bar. Plus and minus, what is my critical value that I'm using this time? T. And what is the standard deviation of my statistic?
Sigma over square root of
Okay, instead of sigma though, it's not sigma, it's S over the square root of n. You should, using this formula, you should be able to come up with any confidence interval that you need. All right, so what is X bar? So now I plug in 5.08 plus and minus. Now I need to look up my critical T. Something you have to write down is how many degrees of freedom you have. So degrees of freedom is n minus 1, which happens to be what in my problem? 14. Okay. All right, so my degrees of freedom, because n was 15 bolts, I'm checking 15 bolts, n is 15. My degrees of freedom is 14. So now we need to look up. To me, it's just easier to look up the 95% in the back of the book. Or you can memorize that 95% is 0.975. So if I go to second distribution, inverse T, 0.975, comma, 14 degrees of freedom, gives me my critical T of 2.145. Is that what your table gives you too? Okay, so 2.145 times, what was my sample standard deviation? 0.11 divided by the square root of 15. So now it's just like we did before. We're going to do this calculation right here. So we're going to take our T, 2.145 times 11, and divide by the square root of 15. And that gives me that I'm allowing, well, that is wrong. 0.11, not 11. I'm like, I am not allowing myself to go 6 away. Wow. And you know, if you're adding 6 to adding and subtracting 6, you know, you should be thinking, well, probably not going to allow myself to go 6 millimeters away. So this ends up being 5.08 plus and minus 0.0609. Actually, you know, since I've got 5.08, I might as well just leave it as 5.0, round it to 2 decimal places. Okay, so now, how do I find my confidence interval from here? Subtract and add 0.06. So if I subtract 0.06, I get 5.02. If I add it, I get 5.14. And this is in millimeters. So now we need to interpret this. Okay, step 4, I'm going to put step 4 up here. Step 4 is up here. So I am how confident? 95% confident that the interval .02 to 5.14 millimeters captures the true mean diameter of what? Of what? What are we finding the diameter of? Of the bolts. Of the bolts. I had to like run down the side here. Okay, I am 95% confident that the interval from 5.02 millimeters to 5.14 millimeters captures the true diameter of the bolts. Yeah, is 5 in there? Okay, we wrote the confidence interval. Now we have to make the conclusion. Now we have to answer the question, decide if I need to adjust the machine. Now this is the key. This is still a part of step 4 really, because I'm making my conclusion. So is 5 in this interval? No, see, this interval represents the size of bolts that the machine is making in that hour. Okay? The 5.08 is the average diameter of the bolts that particular hour. So I allowed it some wiggle room. Okay? Exactly, yep. And it's from 5.02 to 5.14. We're supposed to be making bolts that are 5 millimeters, so what should we say? Adjust the machine. Why? The true mean is not in this interval. 5 millimeters, since 5 millimeters is not in the interval. In the confidence interval, the CI, adjust the machine. Adjust the machine. Since 5 is not in the interval, this represents the current status of what the machine is making. 5 is not in that interval. Okay, you can't help it when you write the confidence interval, you want 5 to be in there, but if it's not, you got to shut the machine down. And they allow it room because shutting a machine down is a bad idea. It just loses time and money. So, all right, so next page. There's just a big blank. Oh, I could have kept writing that. Oh man, I just wasted. I tried to cram it all in. Okay.
Trees are dying because of you.
Yep. Okay, so now let's look at this next example and see what we can get through here. Suppose that the administration of East High would like to estimate the average number of hours students spend doing homework each week. That would be interesting. That would be an interesting study. In a random sample of 50 students, the average number of hours was 6.3 hours a week. So 6.3 is, that's what? That's X bar. And 5.2 hours per week is what? S, good. All right. So find a 99% confidence interval for the true average number of hours that East High students spend doing homework. So let's just, what if we just do the, just do the confidence interval. Let's just do step 3 here. Okay, let's just do step 3. And the conclusion. We'll do step 3 and step 4 here.
Could we, right when we're listing off our points, should we just list off automatically that N is 50 and the F is 50?
That what?
N will be 50.
Oh, yep. N is 50. Yep. And degrees of freedom will be 49. That's a great thing to list. And we're doing 99% confidence interval. Which means that if you're using your calculator, you're going to be doing the 0.995 is your inverse T. All right, so step 3.
I go down to 45, correct? In the table.
Yes.
Okay.
Yep. All right, so step 3, we're going to write our confidence interval. The best thing you can do is write the formula down. So X bar plus and minus T times S over the square root of N with degrees of freedom equals 49. So what's my X bar? 6.3 plus and minus my critical T value. I bet you all have it already, so what do you?
2.6. Well, could we just like go back to when we calculated them already?
No, because the...
Oh, the DF is different.
The degrees of freedom is always, yep, you have to recalculate every time.
This is 2.68.
2.68, other people?
Yep.
There's not 3 decimal places?
Wait, there can...
No,
2.679.
2.679?
The area would be 99.
No, it would, there's
No,
another
it would
9 after that.
2.680.
So it'd be 2.680.
2.68, that's 3 decimal places. The 0 makes it 4, so 3 decimal places.
Did you give a tip? That would be
3.6080 is what it rounds to?
Yeah.
2.680.
Okay. What?
1.779, is that like a?
Did you, after .995, you have to hit comma and then the degrees of freedom?
Oh,
Okay,